Swayam Prabha. Digital India. Educated India.
Hello and welcome. Myself Chandrika Nayak from the Department of Biochemistry at Manipal Academy of Higher Education. Today's topic, as you can see, is alcohol metabolism. Who doesn't know about alcohol? It's a recreational drink from ancient times. It begins because people prefer to have this. Since it's a recreational drink, it's a very good CNS depressant. But once they start drinking it, the problem is it makes them get addicted to alcoholism. And then begins the problems. So today we shall focus on how this molecule called alcohol or ethanol can cause problems to human beings. Let's speak about its metabolism and its ill effects. So first things first, let's begin with the learning goals. So at the foremost, we'll try to understand what is alcohol and alcoholism. Then alcohol or ethanol, as we call it chemically, how is it metabolized in the body? Following which, we will see how ethanol metabolism can be slightly different in chronic alcoholics. And then we have heard that a certain population or certain people cannot take the alcohol drink. They develop some ill effects or aversion. These are the Orientals. So what causes this alcohol sensitivity in Orientals? So after that, we will move on to understand how ethanol can be used as an antidote during acute methanol poisoning. So with these learning goals, let's make a beginning of alcohol metabolism. So what is alcohol? Alcohol is ethanol. It is an alcoholic compound. So both are used as synonyms. So what are the synonyms? Ethyl alcohol or ethanol. How do you get it? It's obtained from natural sources. By the process of fermentation, sugar can be converted to alcohol by organisms called as yeast. It's a different chemical compound. It's very volatile, that means it's organic. At the same time, it's water soluble too. But please remember, this particular compound or alcohol is a high calorie provider and it can easily cross the cell membrane, and maybe that's the reason why it causes so much damage when we consume alcohol every day as a chronic alcoholic. So let's just begin with some uses of ethanol, how it all began. So let's go to the ancient times. We all know that alcohol is known to humans ever since human race is there, that is since ancient times. Now what are the uses of alcohol? Is it just for drinking as a recreational drink or is there something benefit out of it? So it is commonly used nowadays. So if you see, it's a very good antiseptic. It's used in the medical wipes. So it plays a crucial role in the hospital setup. It's a very good antibacterial. If you have happened to use hand sanitizers, it is all alcohol based again. It is a very good medicinal solvent. The mouth washes contain good amount of alcohol. It's an antidote. I told you we are going to discuss this at the end for methanol poisoning. So after all this, let's put the last, which has become the most important point, that is it's a recreational drink, a very good CNS depressant. So what is alcoholism? I think this picture, if you look at the slide, is going to tell you lots about it. It's actually a recreational drink, but when it makes a person a chronic alcoholic, it can destroy his family. It accompanies so many ill effects along with it. So, we can call this as a social misery. So, what is alcoholism? It's drinking alcohol, and by drinking, what are we gaining? It will lead to mental problems, physical health problems. And environment and genetics have deep association with alcoholism. So, please remember that. Along with this, the genes also play a very important role to make a person get addicted to alcoholism. So, both environment, the friendship company, the socializing behavior as well as genes, all this add and make a person a chronic alcoholic, and with that begins alcoholism. Where is alcohol absorbed? As soon as we drink alcohol, it slowly comes into the stomach compartment. How much of alcohol is absorbed in the stomach? About 0 to 5% is absorbed by the gastric mucosa. Where does the rest go? The rest gets into the intestine, and majority of the alcohol is absorbed in the intestinal cavity. And then it finally enters the blood, goes to the liver, and the liver is the major site which handles alcohol. And maybe once it's circulating in the blood, a small percentage might escape in the lungs, and that's why we come to know when a person has drunk, you do his breath test, you can detect whether he has consumed alcohol or not. That's because a small percentage of alcohol escapes in the lung. Why? Because it's a very, very volatile compound. So, let's begin with ethanol metabolism. Where is alcohol metabolized? Which is the major site? All the alcohol that a person drinks through the blood circulation finally reaches one destination, that is liver. So, liver is the major site for alcohol metabolism. Within the liver, within the hepatocyte, where exactly? We ask, what is the subcellular site? So, the subcellular site inside the hepatocyte is the mitochondrial compartment and the cytosolic compartment. A small fraction in chronic alcoholics can be handled by the endoplasmic reticulum also. So, we have three sites, the cytosol, the mitochondria and the ER compartment for alcoholic metabolism. So, who are the chief enzymes involved in metabolism of alcohol? So, let us put down the enzymes involved. The first and foremost, alcohol is acted upon by the enzyme called alcohol dehydrogenase. Where is it located? Inside the hepatocyte in the cytoplasm. What does it produce? It will produce acetaldehyde. Next enzyme, acetaldehyde, is converted to acetic acid with the help of mitochondrial enzyme aldehyde dehydrogenase. Now, what I want you to focus is the last part of this slide, where you can see the endoplasmic reticulum playing an important role. That is, in chronic alcoholics, we know that they can binge on large amounts compared to a person who is a starter. How come these by the years they drink more but still don't develop any symptoms? That is because the last part of the slide, if you see, they are inducing an additional system. What is that additional alcohol metabolism system induced by the chronic alcoholics? It's called the MEOS system, that is microsomal ethanol oxidizing system. So, I repeat now, we have three chief enzymes: alcohol dehydrogenase, acetaldehyde dehydrogenase, and in chronic alcoholics one more additional system is induced called as microsomal ethanol oxidizing system. So, let us begin with ethanol metabolism. Before that, we should know, I told you alcohol to acetaldehyde, acetaldehyde to acetate. Now, who is going to use this acetate? Two places. The first one, muscle, that is, in the muscle acetate can be picked up and it will convert it into energy. So, muscle gets lots of energy. So, that is the first place which can pick up acetate from alcohol metabolism. Which is the other place? In liver itself. Two purposes in liver. One, it gives lots of energy to the liver. Second one, and that is it can be converted to fat and cholesterol. So, chronic alcoholics have this problem. They convert the alcohol to fat and store it either in the adipose tissue or in the liver, and there begins the problem. Liver deposits fat, fatty liver, cirrhosis, and even death of that person if he is a chronic alcoholic. So, we will go step by step. So, first and foremost, you should know ethanol metabolism has two routes, that is alcohol dehydrogenase and aldehyde dehydrogenase. And I told you in chronic alcoholics there is something called as the MEOS system. It is induced in the liver, it handles only 10 to 20% metabolism, and it has a higher Km for alcohol as compared to ADH. So, let us quickly understand the entire metabolic picture of alcohol metabolism. So, let us begin with the reactions of alcohol metabolism. I told you alcohol is absorbed in the intestine, brought by the blood to which important site? It is this site, that is liver. Liver is the major site that handles alcohol metabolism. So, I have a picture of liver here showing compartments in the hepatocyte. I have drawn a mitochondrial compartment, the cytosolic compartment and the endoplasmic reticulum, because these three are the sites where you have the alcohol metabolism enzymes. And I have drawn muscle also because finally acetate is going to reach the muscle. So, let us begin. I have already drawn alcohol dehydrogenase, which is the first enzyme that acts on alcohol, that is alcohol dehydrogenase. What does alcohol dehydrogenase make alcohol to? It converts alcohol or ethanol to acetaldehyde. Acetaldehyde is a very toxic compound, it is a very dangerous compound. So, it has to be quickly picked up and detoxified. So, where does that happen? Acetaldehyde can get into the mitochondria and then can be acted upon by an enzyme called as aldehyde dehydrogenase. So, I repeat, the first enzyme to act on alcohol metabolism is alcohol dehydrogenase. I will write ADH stands for alcohol dehydrogenase. So, that is the first enzyme to convert alcohol to acetaldehyde. Acetaldehyde is next acted upon by aldehyde dehydrogenase. And what does it produce? It produces acetate. And I told you this acetaldehyde is converted to acetate by aldehyde dehydrogenase. This is the mitochondrial enzyme. I will put a star mark here, that is because this is a very good enzyme with very low Km, that means it acts fast in clearing acetaldehyde. It has an isoenzyme in the cytoplasm also. So, you find a similar isoenzyme in the cytoplasm also. So, let us differentiate, let us put the bracket cytosolic. So, this is the cytosolic one, this is the mitochondrial one, and this one also produces acetate. And please remember what happens to this acetate. This acetate can be converted to acetyl-CoA. What is the name of the enzyme? Acetyl-CoA synthase. Acetyl-CoA synthase converts acetate to acetyl-CoA. What happens to this acetyl-CoA? This acetyl-CoA enters the TCA cycle. And what do you get finally from TCA cycle? You get lots of energy. In the beginning itself I had told you alcohol is a high calorie provider. You are going to get lots and lots of energy out of it. That is because alcohol, acetaldehyde, acetate, acetyl-CoA, TCA cycle, lots of energy. Now, this one which is found in the cytoplasm shows small action. That is because it has high Km. It is an isoenzyme with high Km, that means it prefers not to act much on acetaldehyde. So, that is a minor route. whereas this will be the major route. And I told you in chronic alcoholics they have an additional system. That is why I told you even if they binge on large drinks, they do not develop sensitivity or symptoms. That is because they have an additional system. And where is that additional system located? It is in the endoplasmic reticulum. What is the name of that system? The name of the system is microsomal ethanol oxidizing system. So, this alcohol can be converted to acetaldehyde by one more additional reaction, and this happens only in the chronic alcoholics. So, what are you producing in this reaction? Now, that is also important. The first reaction of alcohol dehydrogenase fetches you NADH. Very important molecule. If it enters TCA cycle, it can give us 3 ATP molecules. Similarly, step number 2 also you get NADH. Fine. So, these are the two sites where you get energy additional in the TCA cycle. Whereas, this one, what happens with the microsomal system is, it uses the cytochrome P450 system and you get NADPH. What you have to remember is, if you use alcohol through this system, you will be getting little lesser energy, and maybe probably that is the reason chronic alcoholics won't gain much weight as compared to those who are already drinking. That is because they will be using alcohol metabolism through this pathway also, and this does not fetch more energy. So, rapid weight gain won't be there, or it rather remains same in chronic alcoholic, and that is the reason. Okay. So, what are we going to do with the acetates? With that acetate, it can be picked up by the muscle. So, this acetate either from the mitochondria or the cytosol will enter the blood and come to the muscle, and muscle will convert this to acetyl-CoA and send it to the TCA cycle, and that is how muscle will also get lots of energy. So, again and again if you see, alcohol metabolism fetches us with lots of energy. So, one last time I will repeat: alcohol to acetaldehyde, alcohol dehydrogenase, and then you make it to acetate, and then you get lots of energy. So, though that is about the reactions of alcohol metabolism. Now, I was telling you they have isoenzyme variants. Now, the type of isoenzyme variants. Now, aldehyde dehydrogenase has 2 variants, alcohol dehydrogenase also you are having many isoenzymes. Now, that decides several things. The first and foremost, the rate of alcohol clearance. For some people alcohol is cleared fast, for some it remains there. So, it depends on what genes they have, what enzymes they have. So, it decides the rate of clearance. It decides the degree of inebriation. For some people, even if they drink little, they will start showing the symptoms of toxication, whereas for some, even if they drink lots, no change. That is because the enzyme system in them genetically is different. And susceptibility to liver disease. We have seen some people right from the age of 30 or 40 go on drinking up till the age of 70, nothing happens to their liver. But for some, within 10 years, liver cirrhosis and even death. So, it all decided by the enzymes and the genes and the environment that they are exposed to. So, please keep this fact in mind. The alcohol metabolizing enzymes, alcohol dehydrogenase and acetaldehyde dehydrogenase exhibits several variants. So, coming back to the energy facts, that is, alcohol provides us with lots and lots of energy. How much? Any idea? It is about 7 kilocalories per gram. And how many ATP for one alcohol that you break? Around 13 ATPs you can produce by breaking just one molecule of alcohol through alcohol dehydrogenase mechanism, that is through this route. Whereas, if you use the MAOA system, not 13, you are going to get 8 ATPs. See the difference. You use this system, more energy. You use this system, you are going to get little lesser energy. Why? Because this is going to fetch you NADPH, whereas these two will give you NADH. And then chronic alcoholisms, I just told you, but I am repeating again, they will show no further weight gain because they send a part of the alcohol through the MUOS system. And then we have a myth. People say alcohol has empty calories. Actually, alcohol does not have empty calories. Alcohol is filled with calories. You are going to get energy. What you do not have in alcohol, it is the vitamins and minerals. And these chronic alcoholics can develop vitamin deficiencies. So, what are the variations in ethanol metabolism due to? The rate of ethanol metabolism decides whether a person will develop liver disease, whether a person will develop hepatic cancer, or will he become a chronic alcoholic is all decided. And what are the causes for variation? There are 4 causes. We will try to study those causes. That is the genotype, the genes that we are born with, that decides whether we will tolerate alcohol or not tolerate alcohol. So, what type of ADH do you have? What type of LDH do you have? That decides your destiny. And then drinking history, that is gastric ADH levels are decreased and the MUOS system is increased when you become a chronic drink. That is, when you are moving towards chronic alcoholism, slight changes come in your metabolism. And gender also, females are more sensitive, not the males. Why? Females have less gastric ADH activity. That means it will not be undergoing any change in the gastric compartment, whereas for men, gastric ADH will also be metabolizing little bit of alcohol in the stomach itself. That is why females are more sensitive, prefer not to drink it, whereas males are more comfortable with it. And the quantity is also important. Consumption of the high dose chronically, if you do that, it will induce this system. Every day you drink high dose, this system will definitely turn on, and if this system turns on, then high amounts of free radicals, I told you it is a cytochrome and ER compartment enzyme, it is going to produce dangerous molecules called free radicals, and the free radicals itself can be a cause for destroying his liver. So, the dose and the mode of doing it every day can be dangerous. Coming to the point, why certain people, Orientals, some Chinese population, and you must have seen, they prefer not to drink, because as soon as they drink, they develop the symptoms. What are the symptoms? Acute flushing, tachycardia, heart rate starts increasing, hyperventilation, very uncomfortable, they feel like puking or nauseating. Why? Why Orientals develop this as soon as they drink alcohol? What is the reason? The reason is, look at the board, you can see 2 ALDH. This one is a good one which will not make symptoms come. What has happened in Orientals? They lack this mitochondrial ALDH. They have only the cytosolic one. The cytosolic one is a high Km one, it is very slow. What happens is, if they have only this and not this, levels of acetaldehyde will start rising in Orientals very fast, and acetaldehyde is a very dangerous compound. It is responsible for causing the symptoms. So, I repeat, Orientals lack the mitochondrial ALDH, but have the cytosolic one. Cytosolic one is a poor one to metabolize acetaldehyde. So, acetaldehyde rises and causes the symptoms in the Orientals. So, they prefer not to drink. So, Orientals lack that mitochondrial one, and hence acetaldehyde in the blood rapidly rising causes symptoms. Let us talk about the de-addiction drug. We have heard that chronic alcoholics will be sent to de-addiction camp. They on their own at home can't come out of this habit. They feel like they are having certain symptoms, they feel like drinking again. So, what is the de-addiction drug used? The most common drug used is disulfiram. Where does disulfiram act? Disulfiram is an enzyme which will act on this enzyme. So, disulfiram targets the mitochondrial ALDH, and if it targets this mitochondrial ALDH, what happens? Acetaldehyde rises. If acetaldehyde rises, what happens? Symptoms come in. So, that person who is on de-addiction will immediately stop drinking. So, it inhibits the mitochondrial ALDH, and people who are on this drug prefer not to drink it because it will cause symptoms in them and they will develop aversion for alcoholic beverages. And one last thing which we have to discuss is ethanol really used as an antidote for methanol poisoning? We must have heard, or you must have heard, that certain people drink some local available cheap source of alcohol. They mix methanol with that, and we get to hear stories in the newspaper, so many people died drinking that. Now, why is that due to? Methanol poisoning. But why ethanol is used as an antidote? You bring them to the hospital, they give you ethanol, because ethanol is a competitive inhibitor for this enzyme. So, alcohol dehydrogenase will be inhibited by ethanol. So, that is why people are given ethanol as an antidote to block this reaction, and so that what will happen if you consume methanol, it produces, instead of acetaldehyde, it produces formaldehyde, and formaldehyde is a very toxic compound. That is why people die. And so, you give ethanol, block this reaction, no formaldehyde, you can save the people. That is why ethanol becomes a very good antidote for people who consume methanol and end up with poisoning. So, quick wrap up. Ethanol is a dietary fuel in the alcoholics. Where do we oxidize it? In the liver. And what is that system that develops in the chronic alcoholics? That is the MEOS system. And genotype variants decide whether a person can tolerate alcohol or not. Whether he will develop liver cirrhosis and complication is all decided by his genes. And which is the alcohol de-addiction drug? It is disulfiram. And ethanol, a very high calorie provider, you get about 7 kilocalories for every gram of alcohol that you drink. And what are we going to do with the excess alcohol that you metabolized? You can convert it to cholesterol, fat, and that is the reason why their liver gets destroyed. And Oriental population are very sensitive, cannot drink alcohol, that is because they lack this enzyme, the mitochondrial aldehyde dehydrogenase. So, that is all I had to tell you about the alcohol metabolism. ಇದು ಎಷ್ಟು ಟೈಮ್ ಆಯಿತು? ಇದು MCQs ಉಂಟು ಅಥವಾ ಥ್ಯಾಂಕ್ ಯು ಹೇಳಿ ಮಾಡೋದಾ? ಓಕೆ. Yes, after the summary I think we should ask you some questions. So, just 3 or 4 questions. Let us see, let us test whether you have understood the topic. The first question here, which of the following alcohol metabolism enzyme is lacking in the Oriental population? Which among the 4? Yes, the answer is the mitochondrial aldehyde dehydrogenase is absent in the Orientals, and that is the reason why they are very sensitive to drinking alcohol. Fine. Second question, disulfiram, de-addiction drug, it is used in chronic alcoholics. Which enzyme does it block, inhibit? Which among these 4 is inhibited by disulfiram? Yes, it is the mitochondrial aldehyde dehydrogenase. Then, alcohol provides calorie. How many calories per gram? Next question, calorie value of alcohol 4, 6, 7, 9 for every gram. It is 7 kilocalorie per gram. And one final question, which is the major organ that handles alcohol metabolism? Is it kidneys, lungs, liver, skeletal muscle? Definitely it is the liver which handles the alcohol metabolism. So, thank you.